Bismillahirrahmanirrahim. Last time I talked about this particular theorem. The theorem stated if two angles are supplementary to the same angle, then they are congruent. And I call this affectionately supplements to the same angle theorem. Supplements being two angles that are supplementary to the same angle theorem. And I suggested as an example, let's say this was 150 degrees and angle 2 supplementary to angle 1, that this would be 30 degrees approximately. I'm just making these numbers up. I don't know if these angles are exactly that much or not. So anyway, so if this was 150, angle 2 would have to be 30 degrees if they're supplementary. And if you also tell that angle 3 is supplementary to angle 1, then angle 3 would also have to be 30 degrees, so because they're supplementary angles. So now we have two angles that are supplementary to the same angle. This angle is supplementary to this angle, and angle 3 is supplementary to angle 1. So if two angles are supplementary to the same angle, then these two angles, angles 2 and angle 3, are congruent. That's what the theorem states. It's reasonably easy to understand intuitively, at least I believe this theorem is. So if two angles are supplementary to the same angle, then they are congruent. Today I'd like to prove this theorem, and I hope you appreciate the beauty of everything that we have learned that allows us to prove this. So alright, let's do it. So I'm going to write our two-column proof over here. Here's my two-column proof, and I'm going to put my statements on this side and my reasons on this side. Alright, like that. I'm trying to write a little neater here. So we would have to be given some information over here. And the information given would be as follows. Angle 1 and angle 2 are supplementary. Alright, so that's a given statement. So let's write that. So angle 1 and angle 2 are supplementary. And we would also be given that angle 1 and angle 3 are supplementary angles. Okay, so this is given information. So from this we are asked to prove that angle 2 and angle 3 are congruent. If two angles are supplementary to the same angle, then they are congruent. I just wanted to bring to attention here, it says the theorem says if two angles are supplementary. I mean, there could be more angles. There could be another here, angle 4, also supplementary to angle. So it could be any number of angles, two or more. So this theorem could just say if angles are supplementary to the same angle, then they're congruent. It could be 2, 3, 4, 5, or infinite number of angles, right? So if any number of angles are supplementary to the same angles, then those angles are congruent. But anyways, it's easier to remember the theorem as 2, and then you can apply that to of course, two or more. Anyway, so back to our proof. Angle 1 and angle 2 are supplementary, and angle 1 and angle 3 are supplementary, and this is given information. So from this, well, I don't know what you're going to do with this statement, but you at least can convert that to a mathematical form, right? So what this means, of course, is that two angles are supplementary. That means they add up to 180 degrees. So the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. That's what that statement means. So I got there. So, and then I'm going to rewrite the same thing for the second part. So the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. And that's because of definition of supplementary angles, isn't it? So we have definition of supplementary angles, and I got two mathematical statements. Now look at this. These are statements of equality, and we have a whole table of properties of equalities, right? We have the addition, subtraction, multiplication, division properties of equality for real numbers, right? And then we have RST, the reflexive, symmetric, and transitive property of equality for real numbers, and the substitution property of equality for real numbers, and distribution property of equality for real numbers. Anytime you see equations like this, that table becomes a very good source for finding clues as to what to do next. So we have two mathematical statements over here of equality. Now you see over here, measure of angle 1 plus measure of angle 2 equals 180. Measure of angle 1 plus measure of angle 3 is equal to 180. I could do one of two things. I could use transitive property of equality, because there are two statements that have something in common between them. Okay, so if you recall, transitive property of equality says if A equals B and B is equal to C, then A is equal to C, right? So if that's the case, then A is equal to C. So if I'm always looking for something that's common between two statements like this, so I can use the transitive property of equality. The other thing I could do is actually simply use substitution property to substitute C in place of B. So I could then I could say A is equal to C. So here I could either use transitive property of equality or the substitution property of equality to make these two statements equal to themselves. So I'm actually going to use the substitution property of equality to substitute all of this in place of this 180 degrees, right? That's because that's what your book does, but you can also use transitive property of equality. Now, if you remember, don't get confused with the transitive property of equality. It says if A is equal to B and B is equal to C, then A is equal to C, right? Now, if A is equal to B and C is equal to B, then that means A is equal to C. I mean, don't be looking for ziggity zaggity like that, because here it goes like this, right? So both of those statements are equivalent. But anyways, here we're going to use substitution property of equality for real numbers to get this. Measure of angle 1 plus the measure of angle 2 is equal to measure of angle 1 plus measure of angle 3, like this. And that's because of substitution property of equality for real numbers, if you wanted to say it that way. All right, now what? So now that looks pretty good, because I can just subtract this, right? So I can subtract measure of angle 1 from both sides, and that's because of subtraction property, because that will just cancel those angle 1 on each side, right? So that's what I'm going to do. I'm going to subtract those from both sides, and I'm going to get the following statement. These will cancel out because I'm subtracting them. So the measure of angle 2 is going to equal to measure of angle 3, and this is from subtraction, not substitution. Subtraction property of equality for real numbers, right? Subtraction property of equality. That's my handwriting is terrible. All right, so equality, like that. And I'm almost done, because I got measure of angle 2 is equal to measure of angle 3. I want angle 2 is congruent to angle 3, and I just have to say angle 2 is congruent to angle 3, and that is from definition of congruent angles. So definition of congruent angles. Two angles are congruent if their measures are the same. And there we have our proof, right? So this is a very beautiful proof. Here the theorem was if two angles supplementary to the same angle, 2 supplementary to 1, 3 supplementary to 1, then angle 2 and angle 3 are congruent. So we prove this theorem by writing these two statements as a mathematical statement. And measure of angle 1 plus measure of angle 2 is 180. Measure of angle 1 plus measure of angle 3 is 180 from definition of supplementary angles. Then we use the substitution property of equality for real numbers, or alternatively, you could use the transitive property of equality for real numbers. And we equated these two statements, and we subtracted angle 1 from both sides, and we got angle 2 to be equal, the measure of angle 2 to be equal to measure of angle 3, and by definition, angle 2 was congruent to angle 3, and that was a beautiful proof for this particular theorem. Next, we shall talk about another theorem that we talked about last time, and inshallah try to prove it. We talked about this theorem last time, complements to the same angle theorem. If two angles are complementary to the same angle, then they are congruent. I gave you an example last time. I said, let's say angle 1 here is 60 degrees, and let's say angle 2 is complement to angle 1. For this would be like 30 degrees. So because 30 plus 60 would be 90. So if these two are complements, then this is 60, this would be 30 degrees. And let's say angle 3 is complement to angle 1. angle 3 would also have to be 30 degrees. Now here we see that angle 2 is complement to angle 1, and angle 3 is complement to angle 1. And the theorem says if two angles, in this case angle 2 and angle 3, if two angles are complementary to the same angle, in this case angle 1, then these two angles are congruent. In fact, this would apply to, again, any number of angles. They don't have to be two angles. They could be three angles, four angles. If they're all complementary to the same angle, they would be all congruent. Let's say if I have another angle here, angle 4, and if angle 4 was also complement to angle 1, then all these three would be congruent to each other. So this is another theorem that we learned last time. And the proof of this theorem, again, is very similar to what we did in the other theorem, the supplementary angles. So let's do it, and I'm going to draw out the proof over here. We're given that angle 1 and angle 2 are complementary. So I'm going to write down angle 1 and angle 2 are complementary angles, and angle 1 and angle 3 and angle 3 are complementary angles. So that's given information. And from this, if you recall, we can rewrite this statement as a mathematical equation. Angle 1 and angle 2 are complementary. That means measure of angle 1 plus the measure of angle 2. This is going to equal to 90 degrees, and also measure of angle 1 plus the measure of angle 3 is going to equal to 90 degrees. And this, of course, is from the definition of complementary angles, correct? So now we have angle 1 plus angle 2 equals this, angle 1 plus angle 3 is equal to this. And just like in our previous proof, we saw that in this case we can use one of two things. We can use a substitution property, and we can substitute this entire thing over here like over this, right? And or we can kind of use like the transitive property to derive this next step. Here I'm going to use the substitution property. I'm going to substitute all of this in place of the 90 degrees over here, because 90 degrees is equal to all of that. So then I can say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 3. That is, this is going to equal to this. So that's what I wrote down in that step. And this is because of substitution property. So this is from substitution property of equality. Remember, the substitution property of equality for real numbers. That's from our very important table. So substitution property of equality. And just like in the last proof, we can subtract this from both sides. So you can subtract that, right? And if you subtract that, then you get the measure of angle 2 is equal to the measure of angle 3. And this is from this is substitution. Let me clarify myself. SUB is substitution property of equality for real numbers, and this is from subtraction property of equality for real numbers, right? Subtraction property, so you can subtract that. Now I have measure of angle 2 is equal to measure of angle 3, and final step would be I can say that angle 2 is congruent to angle 3, and that's of course from the definition of congruent angles. So there we have it. So we have proved that angle 2 is congruent to angle 3. This is a beautiful, simple, elegant proof which I hope you appreciate. So we were given that angle 1 and angle 2 are complementary, and angle 1 and angle 3 are complementary. We converted those statements into mathematical equations by using the definition of complementary angles, and then we use the substitution property of equality, and then we use subtraction property equality to simply get a measure of angle 2 is equal to measure of angle 3. From there, we got our the goal of our proof, which was to prove angle 2 is congruent to angle 3. Okay, before we finish, I want to do one last proof over here, and that's this particular proof. given angle 1 and angle 3 are vertical angles. So we're given that angle 1 and angle 3 are vertical angles. So that means that these are two intersecting lines. So vertical angles are non-adjacent angles that are formed when two lines intersect. So vertical angles are two non-adjacent angles. For example, angle 1 and angle 2 are adjacent. They're right next to each other. And angle 1 and angle 3 are non-adjacent angles. So vertical angles are the two non-adjacent angles that are formed when two lines intersect. So that's what we are given. So we're given that angle 1 and angle 2 are vertical angles, which means that these are two intersecting lines. Okay, so two intersecting lines. So that's what the given information means. So angle 1 and angle 3 are vertical angles. And we're asked, in fact, to prove that angle 1 is congruent to angle 3. So before we knew that what vertical angles were, and we knew that they were congruent, here we're actually going to prove that they are congruent from the information, from the knowledge that we have acquired so far. Okay, so let's start with what we're given. So we're given that angle 1 and angle 3 are vertical angles. VERTIs, vertical angles. All right, so that's given information. Okay, so now where do we go from here? All we know really is the definition of vertical angles, which is they're non-adjacent angles that are formed when two lines intersect. Well, okay, well, there's not much to go here. So what I'm going to do now, in fact, is suggest to you that angle 1 and angle 2 are a linear pair, right? They're right next to each other because we learned a theorem about linear pairs. Okay, so I don't know where I'm going with this. Maybe let's just hang tight. Let's see what happens. So I'm going to say angle 1 and angle 2 are linear pair. Okay, I got that. So I got these two to be a linear pair, and then angle 2 and angle 3 are a linear pair, aren't they? So I'm going to say angle 2 and angle 3 are linear pair. Okay, so this is actually also given information because it can be assumed from the diagram, because in the diagram 1 and 2 over here. So this is also given information, and this is from the diagram. Okay, so angle 1 and angle 2 are a linear pair, and angle 2 and angle 3 are a linear pair. And then we learned a theorem in this section that stated that if two angles are a linear pair, then they are supplementary, aren't they? We learned this beautiful theorem. So we learned that if two angles are a linear pair, they are supplementary. So the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Okay, that's because if two angles form a linear pair, if two angles form a linear pair, or we can just say if two angles are a linear pair, then they are supplementary. Right? Then they are supplementary. So there we go. We got that. If two angles are a linear pair, then they're supplementary. In the same way, we can say that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees, because if two angles are a linear pair, then they are supplementary. Now, I hope you see where we're going with this, because now we can say, look, either you can use substitution property or you can use transitive property of equality to get these two statements to be equal to each other, because this is a statement of equality, and we can use all the properties of equality here. So in this case, I'm going to use the transitive property equality to suggest the measure of angle 1 plus the measure of angle 2, the first statement, equals to the measure of angle 2 plus the measure of angle 3. So let's do this. Let's do this with transitive property. So transitive property of equality for real numbers. So we got that. Now, I'm there. So I can cancel these two out, right? Because of subtraction property of equality, then I get measure of angle 1 is equal to the measure of angle 3 because of subtraction property, SUB subtraction property of equality for real numbers. And from this, finally, we get what we wanted to prove, and that is angle 1 is congruent to angle 3. And this is from definition of congruent angles. Ta-da! And here we have it. We just proved that the vertical angles are congruent. I hope you appreciate the beauty in this, because for somebody who has seen these two vertical lines with no knowledge of geometry, it's not obvious to them that vertical angles are congruent. But not only you know that, you can prove that from the knowledge that you have already acquired. We were asked to prove that vertical angles are congruent. We suggested that angle 1 and angle 2 are a linear pair. They form a line, and angle 2 and angle 3 are a linear pair. They form a line, and that means that they both add up to 180 degrees. And by transitive property, or you can use substitution property, we equated these two statements, and by subtraction property, we got that measure of angle 1 is equal to a measure of angle 3, and therefore they are congruent. And I thought that was quite remarkable that we were able to do that. I hope you appreciate the beauty in this and in geometry. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.